Hello everyone. You are watching the classroom study and today we are going to break down invariant subspaces and T-cyclic subspaces. In today's lecture we will discuss the definition of these particular topics and some of key examples. So whenever we have a linear operator capital T, suppose we are having a linear operator T that is defined on a finite dimensional vector space V to V. Okay. Now let me discuss the motivation behind this particular definition. Suppose this is V and we have the linear operator T from V to V. Okay. Now suppose this is some subspace in V. Okay. So this is, we are calling this is W. We are defining the linear operator from T to T from V to V. Okay. Now suppose whenever we choose any element here from V, then its T maze can be here, can be here, can be here, anywhere. Okay. So we may have TV at here. Suppose in V, if we have a subspace W for which whenever we choose a vector from W, that is W, and if we identify the T image of this particular element W, and if it lies in W itself, okay, and whenever the same statement is true for every element of the subspace W, then we call this W as T invariant subspace. So in simple sense we can say, if V has a vector space W in which the T image of every element lies inside the W itself, then this W subspace is known as T invariant subspace. Okay, so this is the scenario behind the definition of T invariant subspace. Now let us start by writing the definition of T invariant subspace. So definition, and this definition defines T invariant subspace. So let this uppercase T be a linear operator on a vector space V, then a subspace W of V is called a T invariant subspace. Of V if T of W contained in W itself. Okay, so whenever you have the image of element of W, it again comes in the W subspace itself. Okay, that is if we have, that is if W belongs to W, then this must implies that T of W lies in W itself only for all W belongs to W. Okay, so this is the T invariant subspace. Now we will discuss कि किसी भी वेक्टर स्पेस V में ऐसी कौन सी ऑब्वियस सबस्पेसेस हैं जो हमेशा हर एक लीनियर ऑपरेटर के लिए T इन्वेरिएंट होती हैं. ठीक है, So let us discuss some examples. Example 1. Okay. For the upcoming these 5 examples, we have the same scenario that T is a linear operator from V to V. T from V to V is a linear operator. Okay, we have the supposition. Now, in the first example, we have that the zero space is T invariant. How we can say that whenever we choose any element, so क्योंकि t एक linear operator है तो zero vector की image हमेशा zero vector पर जाएगी. So we can say since when we choose zero element from zero vector space, then let me write 4 here. For 0 belongs to 0 vector space, we have that t of 0 equals to 0, which implies t of 0 again in 0 subspace. Okay, the things are very obvious, but हमें इसको लिखना कैसे रिप्रेजेंट करना है वो हमें आना चाहिए. Okay, so this implies that t 0 vector space is t invariant. Then in the second one, we have that the vector v itself, v is t invariant. These are obvious examples for t invariant subspace. So how can we prove that? So let t कहाँ से कहाँ define है? V से V में define है. So okay, so let V is any element from V, then since t defined from V to V is a linear operator, right? So we must have t of V must be in V, and that implies that V is t invariant, right? Then come to the third one that deal with the range of t. So we have third one that range of t is t invariant. How can we prove that? We know range of t is defined as, we are again supposing that t defined from V to V. Okay, so it may be possible, suppose we have this V, capital V to V, and for this we have, this is the range of t. It may be possible. Okay, so then whenever you choose any element, then again range will be in this particular subspace only. So let us define the range space of t, and by defining range of t we can easily understood how this particular subspace becomes t invariant. Okay, so range of t defined is t of v where v is coming from V. So this is range of t. So whenever we choose any element from the vector space V, apply t, and whatever the element is coming, that will be an element of range of t. Okay, so this is the definition of range of t. Now choose any element, any kind of element from the vector space V. So now लेट, सो हम ये देखेंगे कि रेंज स्पेस ऑफ टी के हर एक एलिमेंट पर जब हम टी अप्लाई करेंगे तो वापस वो रेंज स्पेस ऑफ टी में ही जाएगा. ठीक है, सो लेट टी ऑफ वी बिलोंग्स टू रेंज ऑफ टी वेयर वी इज एन एलिमेंट ऑफ वी. ठीक है, देन इफ यू अप्लाई टी ऑन टी ऑफ वी, पर्टिकुलरली हम दिस एलिमेंट पर वापस से टी लीनियर ऑपरेटर टी अप्लाई कर रहे हैं. ठीक है, सो इन दैट सेंस वी विल हैव दैट टी स्क्वायर ऑफ वी, राइट? नाउ व्हेनेवर वी हैव दैट टी ऑफ वी इज एन एलिमेंट ऑफ वी, देन इट्स टी इमेज इन वी. ओके, तो हम इसके लिए क्या लिख सकते हैं? सिंस v is in v, this implies T of V is in V, and whenever we have an element from the vector space V, then it's a T image. This implies T of V must be in range of T, right? तो इसका मतलब for this particular element T of V, its range of T, it's a T image of TV is in range of T. So this implies that range of T is invariant, is T invariant. Okay.